In this section, we're going to look at these things called complex numbers. And so what we're going to do first is we're going to start by identifying what the imaginary unit is. And then we're going to also be able to perform addition, subtraction, multiplication, and division operations on complex numbers. And then finally, the whole purpose for us to be able to work with complex numbers is to be able to solve quadratics that do not have real solutions. And so that's what we're going to do, is we're going to solve those types of quadratics. So let's start with the imaginary unit. Okay, the imaginary unit is defined as the square root of -1. And of course, we know that there's no number that multiplies by itself, at least no real number, to give us -1. And so it comes up quite frequently in some applications, such as electrical current, those sorts of things in physics. So it's important for those of you that are going on to be engineers, mathematicians, physicists, to really understand this a little bit. And so what it allows us to do is it allows us to be able to solve those sorts of equations and make some sort of sense of it. And so consequently, because the square root of -1 is I, if we were to square both sides, then clearly by squaring both sides, the square and the square root we cancel out. And so that means we get I squared equals -1. And then if I were to cube I, well, that would be the same thing. Another way to write that would be I squared times I. But we know that I squared is -1, so that would be -1 times I, or -I. All right, so I cubed is the same thing as -I. And then finally, I to the fourth is going to be 1, because we can write I to the fourth as I squared times I squared, which is going to be -1 times -1, which is usually +1. All right, so and then from there, they just keep repeating themselves, because you can always factor off an I to the fourth or a number of I to the fourths to get 1 from that. So that's what an imaginary unit is. An imaginary number is any number that has an I in it. A complex number has this form, A plus BI. So we have a real part, which is the A, and then the BI is the imaginary part. All right, so we have both this real and imaginary parts for complex numbers. And so that's going to be our goal in this section, is to be able to work with those. Okay, so one of the first things that we need to do is we need to be able to add and subtract these complex numbers. It's actually pretty easy. It's just combining like terms. So if you treat the I just like any other variable, or just like a polynomial, then we just add those together. Okay, so let me show you how easy this is. So the first one we have here is this complex number, 3 minus 2i, and this complex number, 4 plus 5i. What I'm going to do is I'm going to combine the 3 plus 4, and that's going to give us a 7. And then we have -2 and +5, which becomes a 3i. All right, and that's literally all you have to do to add two complex numbers. Okay, not meant to be too difficult. Subtraction, just as easy. What we're going to do is we're going to take the negative and we're going to distribute. So this is going to be 3 minus 7i minus 16 plus 13i. And then what we can do is we can combine like terms. 3 minus 16 is -13. -7 and 13 is going to be a +6i. All right. And notice again, this fits the form A plus BI. All right. So A and B are just real numbers. Okay. They don't always have to be integers. Or they don't even have to be rational numbers. They can be irrational as well, which we're going to see a little bit later. When we multiply complex numbers, we're just going to use the same rules as polynomial multiplication. And remember that I times I, so if I was to multiply two i's together, I times I is going to be I squared, which is -1. So don't forget about that rule. So let's just go ahead and multiply. So we have 2i times 5 plus 2i times 2i. So this is going to become 10i plus 4i squared. And remember, I squared is the same thing as -1. So one way to write this would be 10i minus 4. If we were to write it in the form a plus bi, we should probably write this as -4 plus 10i. All right, so that's all we have to do to multiply complex numbers. Just distribute or FOIL it out. So right here we have a FOIL problem. All right, so we're going to take the 7, multiply by both of the terms, 2 plus 4i, and then a -3i, and multiply by those two terms. And so we're going to get 14 plus 28i minus 6i, and then minus 12i squared. Now remember, I squared is the same thing as -1. And one thing that we can do is we can just say I squared is the same thing as a sign changer. Okay, just changes the sign of the coefficient and gets rid of the I square. So another way to write this would be 14 plus 28I minus 6I plus 12. And then finally, to write it in the form a plus bi, we have 14 and 12 is 26. 28 minus 6 is a positive 22I, and that's of the form a plus bi. One last example before we talk about division in the next video is we just have this 6 minus 3i squared. And of course, we know that this is not the same as 6 squared minus 3i squared, okay? The correct way to write this is a FOIL problem. So 6 minus 3i times 6 minus 3i. And so we're going to FOIL. So we have 6 times 6 is 36. 6 times negative 3i is 18i. 6 times, I'm sorry, negative 3i times 6 is another negative 18i. And then finally, we have negative 3i, and negative 3i is positive 9i squared. Again, we have an I squared, which is a negative 1. And so that's going to change the negative 9 to a positive 9. So it'll be 36 minus 36i by combining those two terms. And then finally, minus 9. 36 minus 9 is 27. And then we have the minus 36i. All right, and that's going to be the best that we could do. If we really wanted to, we could factor a 9 from there. All right, so another way to write this would be 9 times 3 minus 4i, although I don't necessarily see a benefit to doing that because it doesn't necessarily make it any easier to look at. All right, so that's how the first three operations, multiplication, addition, and subtraction. Now, in the next video, what we'll do is we'll take a look at division, which is a little bit tougher, but not all that bad.